Okay, so chapter 11.2, tests using contingency tables. The purpose, to test a set of observed values for one variable versus a set of observed values for another variable. So in the example, in a study done by Investigation Original, 276 adolescents in Jamaica, both male and female, were surveyed on what their self-perception of their weight was. The body mass index has 4 categories: underweight, normal weight, overweight, and obese, and these are the results. The hypothesis test would be weight perception and gender are independent, and H1 would be weight perception and gender are dependent. The dimensions of matrix would be rows times columns. Degrees of freedom would be rows minus 1 times columns minus 1. So in this case would be 1 times 3, and your degrees of freedom would be 3. The expected value for each cell is row sum times column sum divided by the grand total. Here are the expected value results for the study. For complementary matrix, the equation is O minus E squared divided by E. E equals the last value we found in the last table, and O is the original value for each square. So for this first one, male underweight, 0 would be the original value, and then 5 squared and 5 would be of what we just found in the last slide. And 118 would be our test value. To find the critical value, we use inverse chi-square. So in your stat list editor, you do F5 and then 2 inverse and then 3 inverse chi. And since it's a 0.05 level of significance, you enter 0.95, and then we already went over that our degrees of freedom is 3. And that would give us, for x squared, 7.815. So we plot that on our graph, 7.815, and then to the right, 118, which is our test value that we found in the last slide. And so we reject and would say gender and weight perception are dependent on one another.